Hey friends, welcome back to a new Python tutorial. Today we'd like to go our first steps in the deep learning framework Pytorch. First of all, what is Pytorch? Pytorch is next to TensorFlow actually one of the two main leading deep learning frameworks when it comes to Python. So whenever you want to create neural networks, you probably want to go with TensorFlow or with Pytorch. TensorFlow is created or was created by Google. Pytorch, on the other hand, is and was created by Facebook. And both frameworks are very interesting and great. And today I'd like to give you the first basic steps with Pytorch. Now, here it's all about tensors itself. Just in case you don't know what a tensor is, you probably know what a matrix is. And you probably know what a vector is. So, a tensor is nothing more than a multi-dimensional matrix with more than 2 dimensions. So, for instance, a 3-dimensional matrix is actually the same as a tensor. And a 4-dimensional matrix would also be a tensor, and so on. For us humans, normally it's most easy to either have a vector, so only a 1-dimensional matrix, or a normal matrix which has 2 dimensions, right? So rows and columns. That would be a matrix. And a 3- and 4-dimensional matrices and so on. So those are more difficult to understand, to see for the human eye, right? So, but this actually is a tensor, just in case you don't know what this is. So, when you want to use Pytorch, you first need to import Torch. So if you're not able to import Torch, you receive an error message. What you do is you install it. If you want to install it using Jupyter, you would probably go with something like pip install Pytorch, like that. And then you should be able to import Torch. Otherwise, have a look at the Pytorch website, the documentation, because of course this is much more deep and gives you exactly what you need. I also use numpy here. The reason why I also use numpy is numpy allows us to create arrays. And when you have an array, you can easily convert this into a Torch tensor. So as an example, I have here the number or vector A actually, which becomes a matrix here with 2 dimensions. And I convert this using the .astype function into a float 32 variable. So if I create this vector here, of course I need to run this first. So let's run it, import the 2 libraries, and now run this again. We have now a vector, or better said a matrix actually, because it's a 2-dimensional vector. We can easily check this. So if I actually remove this here, so let me just go and execute this, go new line, and then go to the first one, and let me remove this here. Okay, and maybe instead of this showing it, let me just comment that out, run this, and you can see it's actually a vector with 2 dimensions, 2 rows, and 2 columns. And if, on the other hand, go inside here, let me comment this out, and let's have a look at the vector. Then actually it's currently an array having 4 numbers, 1 and 2, and 3 and 4. And the data type is also float 32, because this is what we specified here. Now next, when we want to create a tensor from this array, all we do when we have a numpy array is simply call torch.from_numpy. And then we put in actually the array itself. As far as I know, here, at least not directly from .from_numpy, we are not able to specify or change the data type inside this function, as far as I know. So correct me please if I'm wrong in the comments, but that is why I used the astype float 32 up here. Because for the numpy array, we can immediately change the data type up there, and then we can use this immediately in the torch.from_numpy, so we have a tensor in here. And I can execute this, and we can see that the numbers itself are exactly the same. The only difference here is now we have a tensor, in this case a torch tensor. And this is exactly what we need when we use the deep learning framework Pytorch then. Because Pytorch works of course with tensors, not with numpy arrays. So here is an example. I create another tensor with torch.tensor. This would be a second option to create a tensor directly without using a numpy array. So we've seen we can use a numpy array, then convert this array into a tensor, what we did in here in line number 7, or we call torch.tensor and then specify here our, in this case, our tensor. So itself the shapes, the dimensions of the tensor, and then specify here the d type, torch.float. So here, on the other hand, we are able to use the d type attribute here and specify what kind of data type of torch tensor we want to have. And if I execute this, you can see that I get exactly the same numbers as here and exactly the same tensor. So these are the two options we have when we create here tensors in Pytorch. And there are other options as well, but these are the two ones which are probably the most often used. Beside this, you could also use zeros and ones. So for instance, if I call torch.zeros and then I specify 2, 4, and here the d type, so data type, and execute this, I would get here a tensor having 2 rows and 4 columns. So these are the dimensions we specify here, and also the data type is torch int 32. The same would be true if you, instead of calling zeros, you would call ones. So if you have ones like that and execute this, you will get exactly the same, but now you have ones. So that's an easy way to create a torch tensor immediately from zeros or ones. And this can also be done with random numbers, so that would also be possible. So what else? Well, here we have another tensor which gets created, which has again 2 dimensions, 1 and 2 and 3 and 4. We specify the data type here, but this time we do something very important. We set the requires_grad attribute to true. What does this mean? Well, requires_grad, so requiring a gradient, is actually the key of any kind of deep learning, because deep learning relies on backpropagation. So actually converting or calculating an error term and then modify the weights in the network to reduce the error as small as possible. And this can only be done in Pytorch if you set the requires_grad, so the gradient attribute, to true. Because this tells Pytorch, okay, when I want to, or when we want to use the tensor and work with the tensor, then Pytorch will keep the gradients for this tensor in all the operations and will be able to backtrack the gradients. As an example here, we specify, as I said, the tensor here. Then we do some kind of operations. For instance, here the output is the tensor, pow2, so squared, and then we sum it up. And then let's actually execute this, and we get a value of 30, okay? So this is simply the vector squared and then summed. So if you square it, you get, right, you get 1 and 4, which is 5, and you got 9 and 16, which is 25, so 5 plus 25, because we calculate the sum here, is 30, and it has a gradient function. So this function is only there because we set the required_grad to true. And this means we can now calculate the gradients using the output, so our tensor, and call the backward attribute, or sorry, function. So if we call this function or method, you can also name it this way, and execute this, then actually we calculate the actually the backpropagation, or did the gradient calculation. And now if you take a look at the gradient itself, so if I execute this, you get here the gradients for actually the tensor itself and the operation itself, right? So that's how that actually works. And this actually is only another option which I executed here, but the power backward gradient function in here. Okay. So that's basically an introduction to the framework. So the idea is you're now able to create tensors pretty easy, either from numpy arrays or directly using torch.tensor. And you know that in order to actually track all the gradients and do the backpropagation later in your neural network, you need to set the requires_grad attribute to true. Because only then will those gradients tracked, and also you will be able to reduce the error term in the network later on. So hopefully that was interesting to you. If you want to learn more about this, or the TensorFlow framework, or any other kind of things, just let me know and write it in the comments. Beside this, please give the video a like if you enjoyed it, and also Subscribe to the channel if you want to see more, and also click on the bell icon, because then you get notified immediately if I post a new video. So, beside this, stay healthy and hopefully see you in the next video. Until then, best guys.